sketch f of x equals to 2x cubed plus x squared minus 7x minus 6. And we've also got a note, do not label the coordinates of turning points. When we sketch a polynomial, or specifically a cubic like this, our first step is always to factorize it as much as possible. So far, most of the examples we've seen, we were lucky enough that it had been factorized for us. But now we're going to apply our factorizing knowledge to be able to get it to that stage first, using our factor theorem, our factorizing and quadratic factorizing, long division, all of those steps. And finally, once it's fully factorized, we can continue to do the sketching steps that we've looked at already. To sketch, we'll start by finding all the intercepts, and then we'll determine the slope of the graph, which will be either from the sign diagram or by the leading term sign technique, which we've looked at as well. And then after that, we can take note of any other features, like if there's a repeated factor, or if there is one place where it only cuts the axis once. And so that's the sort of features that we'll look at from the factorized form. And then finally, for step 5, we'll use calculus to determine the turning points and label them, and the point of inflection. Now, step 5 is actually an extension topic, so we won't be covering it in this course. However, once you do cover calculus in your course, this will probably be an additional step to this process that you'll need to work on for you to be able to fully label all elements of this graph. However, for us, we will only be looking at step 1 through to 4. So let's begin. We need to start by factorizing this polynomial fully, which we'll start by using the factor law, the factor theorem. For the factor theorem, we're going to test various factors of the final constant term, which is 6. So the factors that we'll test are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. If none of that works, which I really hope it does because it's going to be a lot of work, if none of that works, we can see that it's non-monic, so we can also use the rational root theorem and test combinations of having 2 on the denominator of all of these. But I'm really hoping that we'll be able to find one pretty quickly because there's still a lot to do in this process. So we'll start with testing positive 1. F of 1, not P of 1, so this graph is called F, so I'll call it F of 1 equals, now I have 2 times 1 cubed plus 1 squared minus 7 times 1 minus 6. That gives me 2 plus 1 minus 7 minus 6, which is definitely not equal to 0, so that's not a factor. Next, let's try f of negative 1. 2 times negative 1 cubed plus negative 1 squared minus 7 times negative 1 minus 6. Negative 1 cubed is still negative 1, so this ends up being negative 2. Negative 1 squared is 1, so I'll have plus 1. Minus 7 times minus 1 is plus 7, and I have minus 6. If I go through and add up my negatives together and my positives together, I end up with minus 8 plus 8, and thankfully that's equal to 0. So we have found a factor, and it didn't even take us that long. Our factor is x plus 1. And the reason it's x plus 1 is because we look at what we substituted in, and then we equate that to 0, and then get we equate that to x equals to minus 1, and then we get 0 on one side. So x plus 1 equals to 0, so that's our factor. Awesome, so we've completed the first step of factorizing. The next step is we're going to use long division, which I'll do up here. I'm going to divide x plus 1 into our polynomial, 2x cubed plus x squared minus 7x minus 6. And let's go through our long division process. How many times does x go into 2x cubed? The answer is 2x squared. And then I'm multiplying 2x squared onto this expression here. So I have 2x squared times x, that's equal to 2x cubed. And then 2x squared times 1, which is just 2x squared. I'll subtract that all away from my polynomial, so I have the 2x cubed and the 2x cubed cancel off, leaving just x squared minus 2x squared, which is equal to minus x squared. Bringing the other terms down, and I'm ready. Oh, what happened to my 2x squared there? Oops. So now I'm ready for my next step. So I'm going to do, how many times does x go into minus x squared? That's just minus x. Then I will multiply minus x onto this term here. So I have minus x times x is minus x squared. Minus x times 1 is minus x. Then I'll subtract these away, and I have to be quite careful with the negatives at this point because there's a lot of them. So these cancel off, but then I have negative 7x minus minus x. So I'll even write that here to make it a bit clearer. Negative 7x minus minus x. That's the same as negative 7x plus x, which is equal to negative 6x. All right, let's put that down. Negative 6x, and then bringing down the negative 6 from here. Last step, what is x multiplied by to give minus 6x? That's just minus 6. Then I multiply the minus 6 onto this term, so I have minus 6x minus 6. And subtracting that away, I end up with 0 because it's the same thing twice. And we're done. So we have now factorized up until we have a linear term and a quadratic term. So let's write out our fully factorized steps so far. We have our linear term. I'll write it out. This is f of x. F of x equals to, so we have our linear term, x plus 1. That's from here. And then we have our quotient, 2x squared minus x minus 6. Awesome. Now we're almost ready to sketch. We just need one more thing, which is to see whether we can fully factorize this part of our expression. I'm going to try with the cross method. So I need on the left something that multiplies to give 2x. So I'll do 2x and x. And then on the right, something that multiplies to give negative 6. And in the middle, it has to add up to negative 1. So I might try doing 2 and 3, and I need it to be overall negative, so I'll put a negative there. Let's give this a try. Multiplying along the diagonals, I have negative 4x, and then 3 times x is plus 3x. So I end up with negative x, which is the middle term, so we've got the right thing. Now we can factorize that fully by putting everything down. X plus 1. Now we have 2x plus 3, and then across from here, x minus 2. Awesome. Now none of these can be simplified any further, and so this is my fully factorized version of the polynomial. Now that we have that, we're able to then proceed to sketch the polynomial, and we also take note that we're only labeling the x and y intercepts. We're not labeling any turning points or the point of inflection. Alright, so to sketch this, we'll start by using the null factor law to find the x-axis intercepts. I'll just note down that y equal to 0, and then we have x plus 1, 2x plus 3, x minus 2. Using the null factor law, I get 0 is equal to x plus 1, 0 is equal to 2x plus 3, and 0 is equal to x minus 2. X equals to minus 1. This one we can rearrange in 2 steps, so 2x is equal to minus 3, and then x is equal to minus 3 halves. And this one is x is equal to 2. My coordinates are therefore minus 1, 0, minus 3 halves, 0, and 2, 0. Let's go ahead and draw those in. If I have approximately some sort of scale, I have minus 1 here, minus 1, 0, minus 3 halves, so that's going to be about in the middle. So I have minus 3 halves, 0, and finally 2, 0, which is over here, 2, 0. Now we can look at, we're trying to decide, is our shape going to be like this or like this? This has got the positive slope and this has got the negative kind of overall slope. If I look at the coefficient of the leading term, this is much easier than before because it's already in fully expanded form. So I can literally just look straight at it, I can see that it's positive, so I can immediately tell that my shape will look like this because it's got the positive slope. And when I say slope, I mean kind of like an overall generalized slope. If I drew like a line along it, I don't actually mean that the slope of the whole thing is positive, because actually in this section it does have a bit of a negative gradient. Alright, so I know it's got that overall positive slope, so I'll start down the bottom. I'll go through a point here, down, and then back through here and up. Alright, now the last thing to label is that y-intercept. So we'll say let x equal to 0. I think I'll use this one because it's a bit easier. So if I do f of 0, all of these terms get killed off by the 0, so I'm just left with minus 6. So I can just go and put 0 minus 6 as my coordinate over here. And since this is a negative point, we're quite right with our shape because we have it crossing on the negative side of the y-axis. Alright, let's just label the graph as f of x. And that's it, we're done. So it was quite a long process. For us to be able to sketch this, we had to start by using the factor theorem first to find a linear factor. Then we had to use long division to factorize it into a linear term and a quadratic term. Then we had to use the cross method, or it could be any other method, to see if we can factorize the quadratic term further down into two linear factors. And then after that, we had to go ahead, find our x and y intercepts, determine the direction of the shape, and then we were able to finally sketch our cubic graph with this as the result.